How's it going?
Just looking at the sky.
Well, exactly what are you looking at?
Come, I will explain. You know, we have trillions of stars, billions of galaxies, and millions of solar systems.
Interesting. What's next?
You know, our Earth is a part of a solar system in Milky Way galaxy, and just think about the discoveries of the surface of the moon and other planets.
Well, I get it. Well, imagine if we go to the space discovering other solar systems and planets.
It is fabulous, isn't it?
Yeah, it is. Well, I've got an idea. What say we go and visit the Astronomy Club exhibition represented by SRN International School?
Well, that's great, but at least give some hint about it.
Well, we'll get to learn about the sun, the galaxy, the space, and more other topics.
Okay, great. We will surely go there.
The night sky is a cosmic time machine. Whenever we observe a distant planet, star, or galaxy, we are seeing it as it was hours, centuries, or even millennia ago. This is because light travels at finite speed, and given the large distance in the universe, we do not see objects as they are now, but as they were when the light was emitted. The time elapsed between when we detect the light here on Earth and when it was originally emitted by the source is known as look-back time. For every distance of the look-back time is increased by the Hubble expansion of the universe, which is causing the space between galaxies to increase with time. Now, got it?
Yes.
See, when you are looking at the sky, this question raises the fascinating issue of look-back times. Because of the finite speed of light, when you gaze up into the night sky, you are looking into the past. The brightest star, Sirius, is 8.6 light years away. That means the light hitting our eye tonight has been traveling into 8.6 years. Put the another way, when you look at the Sirius tonight, you are seeing it as it was 8.6 years away. As you look at more distant objects, the effect becomes bigger and bigger. The stars of Big Dipper range from 60 to 125 light years away. When you look at Dubhe, the front star of the ball of the Dipper, you are seeing the light before you were born.
Another captivating example could make you feel more exciting about this fact that if an alien 65 million light years away sees the Earth through a powerful telescope, they can see dinosaurs. This is how it is said, right, that when you are looking at something, you are actually looking at its past.
A person can endlessly stare at three things: a burning fire, running water, and other people working. I propose adding one more item, that is, the photos taken by Hubble Space Telescope. This telescope takes sharp pictures of objects. We have witnessed the birth of new stars, found planets outside the solar system, and see supermassive black holes. It was not the first space telescope, but it is one of the largest and most versatile, renowned as a vital research tool for astronomy. It was launched on April 24, 1990 from Kennedy Space Center, Florida, and named after Edwin Hubble, an American astronomer. Hubble features a 2.4 meter mirror and its telescope takes sharp pictures of objects. We have witnessed the birth of new stars, found planets outside the solar system, and see supermassive black holes. It was not the first space telescope, but it is one of the largest and most versatile, renowned as vital research tool for astronomy. It was launched on April 24, 1990. Hubble's orbit outside the distortion of atmosphere of Earth allows it to capture extremely high-resolution images. It has recorded some of the most detailed visible light images, allowing a deep view in space. Many Hubble observations have led to breakthroughs in astrophysics, such as determined in rates of expansion of the universe. Space telescopes were proposed as early as 1923, was founded in 1970, and built by United States Space Agency NASA with contribution from the European Space Agency. Its intended launch was 1893, but the project was beset by technical delays, budget problems, and the 1986 Challenger disaster was finally launched in 1990. Retired Hubble telescope has served this universe for 30 years, being the most powerful till date.
Our Sun is a 4.5 billion year old star, a hot glowing ball of hydrogen and helium at the center of our solar system. The Sun is about 93 million miles away from Earth, and without its energy, life as you know it could not exist here on our home planet. The Sun is the largest object in our solar system. The Sun's volume would need 1.3 billion Earths to fill it. Its gravity holds the solar system together, keeping everything from biggest planets to the smallest bits of debris in orbit around it. The hottest part of the Sun is its core, where temperatures top 27 million degrees Fahrenheit. The Sun's gravity, from its powerful eruptions to the steady system of charged particles it sends out, influences the nature of space throughout the solar system. NASA and other international space agencies monitor the Sun 24/7 with a fleet of spacecraft studying everything from its atmosphere to its surface, and even peering inside the Sun using special instruments. Sun exploring spacecraft include Parker Solar Probe, Solar Orbiter, HINODE, Solar Dynamics Observatory, and Stereo. Pop culture. The Sun has inspired pop culture since ancient times. It's central to mythology and religion in culture around the world, including the ancient Egyptians, the Aztecs of Mexico, Native Americans, tribes of North and South America, the Chinese, and many others.
What is a dwarf planet? A dwarf planet, as defined by the IAU, is a celestial body in direct orbit of the Sun that is massive enough that its shape is controlled by the gravitational forces rather than the mechanical force, has not cleared its neighboring region of other objects. So the three criteria of the IAU is a full-size planet are: 1. It is in orbit around the Sun. 2. It has sufficient mass to assume hydrostatic equilibrium, a nearly round shape. 3. It has cleared the neighborhood around its orbit. Pluto meets only 2 of these criteria, losing out the third. In all the billions of years it has lived there, it has not managed to clear its neighborhood. What that means, not clearing its own neighboring region of other objects. Sounds like a minesweeper in space. This means that the planet has become gravitationally dominant. There are no other bodies of comparable size other than its own satellites or those under its gravitational influence. Sounds like a vicinity in space. So any large body that does not meet this criteria is now classed as dwarf planet, and that includes Pluto, which shares orbital neighborhood with Kuiper belt objects such as the Plutonous. In 2006, the International Astronomical Union demoted the much-loved Pluto from its position as the ninth planet from the Sun to one of the 5 dwarf planets. The IAU had likely not anticipated the world-spread outrage that followed the change in the solar system's lineup. When the announcement was made, and even over the 10 years later, people around the world objected the planet's demotion on principle, saying it is altered tradition and history rather than engaging with the scientific reasoning. So, what was the IAU's reason for demoting Pluto when it died? Why is Pluto no longer a planet? The main event of 2006 General Assembly of the IAU, the proposal that would come to remote Pluto, was the defining movement for the rest of the solar. What was once a loose word used to describe a large object within the solar system was now specific. Planets are celestial bodies large enough to be made rounded by the gravitational orbit around the Sun and to have shooed away neighboring planetary objects and debris. Pluto is now classified as a dwarf planet because while it is large enough to have become spherical, it is not big enough to exert its orbital dominance and clear the neighborhood surrounding its orbit. In 2006, the term planet had no working definition and was based on classification from before some of the major modern discoveries within the universe that were made possible by advanced technology. To many citizens of Earth, the emotion of Pluto felt like a break from tradition and it was precisely that a positive step forward into a new light, new knowledge and new changing perspective of the universe.
The Andromeda Galaxy, also known as Messier 31 or NGC 224, and originally it is paired spiral galaxy, approximately 2.5 billion light years from Earth and the nearest class galaxy to the Milky Way. The number of stars contained in it is estimated at 1 trillion, although several dozen minor galaxies lie closer to our Milky Way. The Andromeda Galaxy is the closest large and small Magellanic Clouds visible from Earth's southern hemisphere. It is the brightest external galaxy you can see. It's very hard to see, and it was the book of the fixed stars.
Geosynchronous Satellite Launch Vehicle Mark II. GSLV Mark II is the largest launch vehicle developed by India, which is currently in operation. The fourth stage generation launch vehicle is a third stage vehicle with 4 liquid strap-ons. The indigenous development cryogenious upper stage, which is flight proven from the third stage of GSLV Mark II. From January 2014, the vehicle has achieved 4 consecutive successes. GSLV is an expendable space launch vehicle designed, developed and operated by Indian Space Research Organization ISRO. It is a third stage vehicle with a lift of mass of 420 tons. The GSLV project was held in 1990 with the objective of acquiring Indian launch capability for GSLV. The first development flight of GSLV Mark I configuration was launched 18th April 2001 was a failure as the payload failed to reach the intended orbit parameters. Kiran Kumar, ISRO's chairman, said, "Till now GSLV Mark II can put 2.2 ton satellite into geostatical orbit, but GSLV Mark III can put a 4 ton satellite into geo orbit and even 8 ton satellite in low Earth orbit."
Quasars are highly luminous objects which allow astronomers to understand the evolution of galaxies. The further the quasar is, it takes a longer time for the light to reach us. So any quasar billions of light years old will provide information about life billions of light years ago. There are many subtypes of quasars that display distinct properties. In no particular order: radial out quasars, radioquoid quasars, board absorption line quasars, type 2 quasars, red quasars, optically violent quasars, weak emission line quasars. Quasars emit energies of millions, billions or even trillions of electrons volts. The energy exceeds the total of the light of the all stars within a galaxy. The brightest objects in the universe, they shine anywhere from 10 to 1 lakh times brighter than the Milky Way. Quasars are highly luminous objects that allow astronomers to understand the evolution of galaxies. The further the quasar is, it takes a longer time for light to reach us. So any quasar of billions of light years old will provide information about life billions of light years ago.
Gravitational waves are the ripples in space-time caused by some of the most violent and energetic processes in the universe. Albert Einstein predicted the existence of gravitational waves in 1916 in his general theory of relativity. Einstein's mathematics showed that massive accelerating objects such as neutron star or black hole orbiting each other would disrupt space-time in such the way the waves of undulating space-time would progress in all directions away from the source. These cosmic ripples would travel at the speed of light, carrying with them information about their origin as well as clues to the nature of gravity itself. The strongest gravitational waves are produced by cataclysmic events such as colliding black holes, supernovas, massive stars exploding at the end of their lifetime, and the colliding neutron waves are predicted to be caused by the rotation of neutron star. There are not perfect spheres and possibly even the remnant of gravitational radiation created by Big Bang.
PSLV, Polar Satellite Launch Vehicle, is the third generation launch vehicle of India. It is the first Indian launch vehicle to be equipped with liquid stages. After its first successful launch in October 1994, PSLV emerged as a reliable and a versatile workhorse launch vehicle of India, with 39 consecutively successful missions by June 2017. During 1994 till 2017 period, the vehicle had launched 48 Indian satellites and 209 satellites for customers abroad. Besides, the vehicle successfully launched 2 spacecrafts, Chandrayaan-1 in 2008 and Mars Orbiter. The technical specifications of PSLV: payload to SSPO, which is 1750 kilograms. PSLV earned its title, the workhorse of ISRO, to consistently delivering various satellites to low Earth orbits. Particularly, the IRS series, it can take up to 1750 kilograms of payload to sun-synchronous polar orbits of 600 km altitude. Payload to sub-GTO, which is 1425 kilograms. Due to its unmatched reliability, PSLV has also been used to launch various satellites into geosynchronous and geostationary orbits, like satellites from the ISRN constellation. The fourth stage, PS4. The PS4 is the uppermost stage of PSLV, comprising of 2 Earth-storeable liquid engines. The engine used over years 2 into PS4 and the max thrust provided is 7.6 into 2 kilonewtons. Now comes the third stage, PS3. The third stage of PSLV is the solid rocket motor that provides the upper stages high thrust after the atmospheric phase of the launch. The fuel used is HTP8 and the max thrust provided is 240 kilonewtons. Second stage, PS2. PSLV uses an Earth-storable liquid rocket engine for its second stage, known as the Vikas engine developed by the Liquid Propulsion System Center. The engine uses Vikas and the max thrust provided is 799 kilonewtons. PSLV's first stage is PS1. PSLV uses the S139 solid rocket motor that is augmented by 6 solid strap-on boosters. The engine uses S139 and the max thrust provided is 4,800 kilonewtons. The strap-on motors. PSLV uses 6 solid rocket strap-on motors to augment the thrust provided by the first stage in its PSLV G and PSLV XL variants. However, strap-ons are not used in the co-alone version, PSLV CA. The fuel used over here is HTP8 and the max thrust provided is 790 kilonewtons.
Hello everyone, I am Kritika Mani is here to tell you about Curiosity rover. Curiosity, also called Mars Science Laboratory, US robotic vehicle designed to explore the surface of Mars, which determined that Mars was one capable of supporting life. The rover was launched by an Atlas V rocket from Cape Canaveral, Florida on November 26, 2011 and landed in Gale Crater on Mars on August 6, 2012. Curiosity is about 3 meters long and weighs about 900 kg, which make it the longest and heavier rover on Mars. By contrast, the Mars exploration rovers Spirit and Opportunity are 1.6 meters long and weighs 164 kg. Unlike previous rovers, Curiosity did not have its landing cushioned by air bags. Rather, because of its large size, it was lowered to the surface by a 3 tether from the spacecraft body called the Sky Crane. The landing sequence was highly integrated after a parachute significantly slowed the vehicles and after its heat shield, which had protected the rover during its entry into the atmosphere, was discarded. The spacecraft was eased toward the planet's surface by rockets that established the vehicle, allowing it to hover and protecting it from horizontal winds. Curiosity had also shed its protective shell on the way to the planet's surface, and its mobility system, wheels and suspension had already been released while still in the air. Curiosity was therefore ready to rove immediately after it landed, unlike the Mars exploration rovers, which had to wait for their pedals that enclose the rover to open. Once downloads to Curiosity have occurred, onboard computer released the tether. The Sky Crane then pitched away the crashed far from Curiosity. All told, there were 15 critical steps involved in the landing sequence, and all of them had to be executed flawlessly for the mission to succeed. This sequence took approximately 7 minutes, an interval referred to in NASA circle as the 7 minutes of terror.
In astronomy, the interstellar medium ISM is the matter and radiation that exists in the space between the star systems in a galaxy. This matter includes gas in ionic, atomic and molecular form, as well as dust and cosmic rays. It fills interstellar space and blends smoothly into the surrounding intergalactic space. The energy that occupies the same volume in the form of electromagnetic radiation is the interstellar radiation field. The interstellar medium is composed of multiple phases, distinguished by whether matter is ionic, atomic or molecular and the temperature and density of the matter. The interstellar medium is composed primarily of hydrogen, followed by helium with trace amounts of carbon, oxygen and nitrogen comparatively to hydrogen. The thermal pressure of these phases are in rough equilibrium with one another. Magnetic fields and turbulent motions also provide pressure in the ISM and are typically more important dynamically than the thermal pressure is. The ISM plays a crucial role in astrophysics precisely because of its intermediate role between stellar and galactic scales. Stars form within the densest regions of the ISM, which ultimately contributes to molecular clouds and replenishes the ISM with matter and energy through planetary nebula, stellar winds, and supernova. This interplay between the stars and the ISM helps determine the rate at which a galaxy depletes its gaseous content and therefore its lifespan of active star formation. Thank you.